Alright, so we're going to start out by doing f of x equals x to the 2/3, and we're going to do domain and range. Plug this into y1 and then hit zoom 6, and what you'll see is that you have a graph that looks like that. So let's find the only max for min, which is the minimum right there. So second calc 3, and this point turns out to be 0, 0 when you notice that the scientific notation is e to the negative whatever again. So the domain here is all reals. The range here, well, the lowest y value is at 0, and then it keeps going up in each direction. Now it's not going fast up, but it's going to keep going up and up. So when you get to the 1,000,000 to the 2/3, it's going to be higher. 10 million will be even higher. So we have basically 0 is less than or equal to y. Or you could have said it as y is greater than or equal to 0. So this graph starts out over here by decreasing. So it is decreasing when x is less than or equal to 0. And it's increasing on this side when x is bigger than 0. The or equal signs don't really matter. I probably shouldn't include them, but it's okay if you do. I won't take off, just so long as you have the inequality pointing in the correct direction. Alright. We are going to talk about local max and local mins. Whenever you see a point at the top of its area, that is a local max. When you ever see it as the lowest one, that's going to be considered a local min. So when we graph f of x equals x cubed minus 8x plus 1, we're going to try and find the local max and the local mins if we can find them. With zoom 6 on our graph, we still have enough room to see the max and the min. So here's my max, here's the min. So second trace 4 to get the maximum. Make sure that you put a left side, then right side, and then don't worry about guessing. And it turns out that the maximum is, the local max is at negative 1.63, comma 9.71. And the y value is really the value of the maximum. If we do it again for second trace 3, on the left side, then on the right side, so about here and about here, we wind up with a minimum at positive 1.63, comma negative 7.71, and that would be the actual value. They give us the entire point. And that's how we find maximums and minimums, domains and ranges, increasing intervals and decreasing intervals from looking at a graph.